Okay. Again, 10 to the power 4. Anyone? Any dispute?
Wait, I have this. Me.
I
Me
also.
Oh,
Yeah.
Wait.
okay.
Okay. Yeah.
Okay, 2 versus 1.
Because if they can. Okay.
Okay, never
Yeah,
mind.
if,
Go
if
back.
there's only, but this is given that there can only be at least one book, right? What if there's a case where one kid can have two books? If one kid can have two books, then it means that it can be 10 power 5 because there'll be 5 slots, right? I don't know.
Oh.
It could also be like 10 for one and none for the rest.
This sort of problem, right? Once you detect that you have these multiple number of books and objects, right? You need to distinguish who is receiving, who is giving. Yeah, there's a receiving end and a giving end. So in this case, you'll find that the books are the giving. Right? You have to give the books. And give the books to who? To the 4 people. Yeah, so you think in this way. If that's the case, then every book will have 4 choices. Because there's no limit on who will receive how many books. So there'll be 4 choices. So for each of them, so it's 4 to the power 10.
Wow.
Because each book, the first book has 4.
10.
Yeah. Wait. So it's 4 to the power 10 because it's first book has 4 choices, second book has 4 choices, third book has 4 choices, and so on. So until the last book also has 4 choices, 4 people to give to one of them. Okay.
Actually, I thought that is like 7, 4 to the power of 7 or 7.
Oh, why 4 to the power 7?
Because like if you want at least one person to receive one book, right, then each person can at maximum receive 7 books.
Oh. Okay. So what to do?
I don't know.
So it's 7,
Like each slot is got 7 options. So there's 4 slots, then 7 options. So can it be like set of m?
Then
Can it be like 7 to the power of 4? Cannot, right?
No, cannot.
Okay.
This number is very familiar to us, because it's like every person, the book, right, can be given for. You get what I mean? 4 to the power 10. So every book has 4 people to give to, but this will not work for this question because they want at least one book, right? Yeah, because 4 to the power 10.
They have more than one, what? That's why.
Because some people will not receive any book if you do this method. You get me? It could be a situation where one person receive all the books, but the other 3 people no book.
So the answer is 10 to the power of 4?
No. Also no. Yeah, you need to be careful. If you want to have at least one book for each person, right? Then first of all, you fill up each one book. You get what I mean? Because the books are not are distinct. Oh, are distinct. Okay. Who said this answer? Kai Xing, you explain again why.
They're too small. Wait, I have no idea. Isn't it because it's 10 distinct book, then 4 people getting it?
Then why 10 to the power 4? Okay.
Wait, I don't know.
Working will be something like that. sorry, it's not my intention to set question like that. I actually wanted you all to just if I cancel this part away, what would be the answer?
10 to the power of 4.
10 to the power of 4, yeah.
This one. Remember? Because each book will have 4 people to give to. Yeah. It's not 10 to the power of 4 because 10 to the power of 4 is actually what does that mean? What does that mean by 10 to the power of 4?
10 to the power of 4 means that there's 4 choices. There's 4 slots and 10 choices. 4 boxes and 10 choices.
Yeah, 4 boxes and 10 choices.
But for the 7 to the power of 3 is 3 boxes and 7 choices, what? So for 10 to the power of 4, shouldn't it be 4 boxes and 10 choices?
I didn't say this is correct. Yeah, I didn't say this is correct.
For part A,
Part A, huh? Oh, part A. Why you
Yeah.
mentioned 7 to the power of 3?
Because I answered 7 to the power of 3, and there's 3 boxes and 7 options.
Yeah, talk about part A lah.
Yeah.
Yeah.
So if 7 to the power of 3 is correct for 3 boxes and 7 options, then shouldn't 10 to the power of 4 be correct for 4 options and 4 boxes and 10 options?
Because here in this case, this 7 to the power of 3, right, is actually given to 3 boxes. But here, this one is how many boxes?
4.
Wait lah.
Wait, Mr. Lau, but isn't it the distinct objects one, right, will be the base? Then the number of objects will be the power.
Then isn't the Amy, Ben, Che, Don the distinct objects? Then the option is the books, because you can replace them.
Yeah.
Okay. If let's say you have 10 boxes, let's say there are 10 boxes. Yeah. Then now, if you are talking about the first person, yeah, let's look at this. You see what will happen. If the first person, let's say Amy, so how will you give the book to Amy? You say, oh, Amy got 10. Cannot, right? Cannot. Because once Amy took the book away, the book is gone already. It's not replacement.
Oh, because they said just now it's 10 distinct
but
story
I feel like
books,
you
is
need to
it?
minus all the, because if it's 10 choose 4, right? If it's 4 choose 10, right, it means that
4 choose 10 or 4 power 10.
Where all the books go to Amy, or all the books go to Ben, or like Dawn doesn't get a book.
Yeah.
Because it can be DD, right?
Yeah.
So we have to take away all those time.
Correct.
Which is like not easy.
Correct.
Oh, this is so complex.
Correct. But that's why I take away this sentence. It's too difficult for a start. Can for those Kai Xing and Grander, you see that the boxes are not the book.
The boxes are what?
They are not the book. In this case.
Then there are Amy, Ben, Che, and Don.
They are the boxes. Yeah.
Sorry?
How
come? But I thought they are like distinct, like different people.
Okay. You see, let's say Amy, you cannot say, Amy, I have 10 books. Then so Amy got 10 choices, right?
Yeah.
Then when it comes to Ben, how many choices does Ben have?
0.
Huh?
Wait, I see a 9.
You also don't know. If you arrange in this way.
Oh, because she can choose any
number
of.
Yeah.
Oh, okay.
Yeah. So this
so it's based on. Oh, so it's based on the books,
Yeah, it's not always say that the boxes must be whatever. No, you have to look at in a practical sense, which one is the receiving end. Okay, in this case, Amy, Ben, Che, and Don, they are they are receiving the books. So they are the one who are able to receive different types of books and so on. Yeah. Okay. So yeah, it's a little bit different from part A. Yeah. Can I hope you all get. It's not, there's no one formula to say, oh, that is the box, that is the receiving and so on. So it depends on the situation. Yeah. Bernice, okay?
But how do you ensure that
Easy.
with oh, it's okay, I understand already.
But if you really want to solve this question of each person has at least one book, then how to solve?
I don't know.
How to solve? There's a way to solve, but it's complicated. It will involve your combination already. For example, you have to look at things like
is it the slot method?
not slot method, but rather is for example, you say
is it 10 times 9 times 8 times 7? Is it?
No. I think it's more complicated.
Okay.
Yeah, it's much more complicated.
Okay.
So, we didn't do with this part first. Okay, cancel this part. It's very difficult to do.
Okay.
It's
so if everyone only has one book? Oh, you just have the
everyone has one book, then it's simple.
Then if everyone has only one book, we 10 4, but if we doesn't have that, we 4 10. Is it?
Yeah, that means you have to choose 4 books out of the 10. Then you give them 4 factorial. Okay, so it's different. But if they want at least one book, it's different. Yeah. It's more complicated. Okay, next one.
If we do by 10 choose 4 times 4 factorial.
This is for only one book each. Oh, I didn't kick her out. She out herself. Okay. Yeah, this is only for one book each. 10 choose 4 times 4 factorial is one person, one book. Can? Then if you want to solve, that's the meaning of 10 choose 4. What? 10 choose 4 means you choose only 4 books. Choose only 4 books to give to the 4 people. So it's 4 factorial. If you want to solve this question,
then the 4 factorial is to divide within the 4 people, right?
Yeah.
Because each person has 4, then 3, then 2, then 1 options, right?
Correct.
Okay. Can.
So this question, the answer again. What is the answer? Remember?
4 to the power of 10.
Okay. So without the restriction, with restriction is very complicated. Okay. Next one. I'm going through some of the common types of situation. Okay. So this one you also remember you did in school. Identical objects. Yeah. So you have to divide by the identical objects factorial, the types. Yeah. Let's look at example A. This time round I want Ming-Si to answer. Ming-Si, you did in school, right? Now I can hear about better.
Yeah.
Okay. So let's look at this. How many ways to hang 4 red identical hats and glue 5 of them on a straight bamboo stick in the shop house? Okay.
Is it 9 factorial, thereby 5 factorial, and then 4 factorial?
Wow. Is it
Yeah.
Yes Okay, good.
Yes.
Yeah, correct. So wait let's see. So far no one answered the question correctly except first question I can give a throw. You two before. Okay, because
why
y'all chose this answer.
I did the A, yeah.
Yeah, I did A. Right. No So Ming-Si, sorry. Kai-Xing, next one. Okay, repeated. So how many code words can be formed with the digits? Such that each code word starts with an even digit.
Is it 7 factorial divided by 4 factorial times 2 factorial?
Divided by 2 factorial?
Times 4 factorial.
Minus 1.
Oh, why minus 1?
Because you have to start with even digit, but it's only one that is not just 3.
But altogether is 8.
There are 8 digits.
So she minus 1 already.
Oh,
So each code word starts with even digit, but there's only one that's odd.
no. So,
Okay.
so how? Kai-Xing, anything to amend? How come 7 factorial?
Correct. Yeah.
I don't know, is it wrong?
No, I'm
It's
asking you to
correct.
explain.
Wait, cause there's 8 digits, right? But then one of them is a odd number.
Yeah.
So if you want even numbers, it's just 7 digit. Yeah.
Mm.
Then the divide one is because for digit for number 2, right, it's 2 repeated. Then for number 8 it's 4 repeated.
Is it correct?
Wait, but I feel like
Hmm?
cause how many codes can you form with the digits? Wait, code word as in like, so it's like just change the order, is it?
Yeah, just change the order.
Oh, cause
Yeah, codes are
sometimes what if there's a tree inside, you know? There might be the tree inside. Like if you versus you just take out. So the only situation where each code word will start with an odd digit, which is like not included, which is when 3 in front. But there's only one situation.
But the thing is,
Cause like
yeah.
okay, it can be like 2, okay, like 2, 4, 2, 8, 8, 8, 8 or whatever, but then the 3 can be any number inside 7.
Yes.
Oh wait, no, I'm wrong. Okay, I'm gonna sit down. Okay, I think it's not correct. Yeah.
Okay, let's check. Very dangerous. This method is very dangerous. It's correct.
Is it
No,
but
no,
is it
no,
still
wait.
is it
I feel
still
like
8
correct.
factorial, Mr. Lau?
But it can be okay.
Not
The
8
thing is
factorial.
that okay. I feel like you need to stop.
It's not
the
8
tree,
factorial.
because right,
No.
this is the answer if the 3 didn't exist. But then it could be as long as 3 is not in front. So like it could be.
Yeah,
2,
but the
3,
thing is,
2.
they said permutate n objects, right?
Mm.
Then like
Yeah.
there's 8 digits, right? So shouldn't it be 8 factorial over something? Then you minus something off.
Okay. When you do the situation like that, right? I feel it's dangerous lah. Dangerous. Okay, dangerous. Why so? You see, for example, let's say I put the 2 in front. Okay, if I insist that 2 must be starting digit, then how many ways to arrange the rest of the digits?
Is it we must do like 3 cases?
Yeah. I'm just asking you this question lah. Yeah. So if the 2 is in front first, then how many ways to arrange the digits to form a code word?
7 factorial over 4 factorial.
Yeah, over 4 factorial, right? Do you see different? It depends on which digit is in front. So let's say I have a digit 8 in front. Yeah, then how many ways to arrange them? Will be 7 digits left, right? But now there'll be 2 factorial coming from the 2.
And 3 factorial.
The remaining 8, 3 of the 8s that will constitute identical. So you can see that depending on which number is in front, which digit is in front, the number of ways calculated may be different. Yeah, so this bracket formula is a bit dangerous lah. Kai-Xing, you get me? So here, if you are doing it in this case, will be and of course the last case, if the 4 is in front, then will be 7 factorial over 2 factorial, 4 factorial. Do you see this?
Oh, Mr. La, I know the other way to do. Is it 8 factorial over 2 factorial 4 factorial minus 7 factorial over 2 factorial 4 factorial.
Yeah, correct.
Okay.
Correct. The rest of you understand?
Wait, what did Glenda say?
Wait, what's the other formula? What's the other method?
Yeah, what's the other
Complement method.
Yeah, she so advanced already. She's finishing. Yeah, so it's complement.
Wait, what? Oh, okay.
Complement is
What
Like
is
you take-
possible to like? Okay, you go first. You go.
save. Who will say first?
Oh, Glenda first.
Wait, what?
You go first. You explain the complement. Oh, he's doing it.
No, Mr.
Yeah,
Lau has it already. He's the math teacher.
Oh, okay.
No. I mean, just write it out.
Okay.
Oh, I copy.
Wait, Mr.
Wrong.
Lau, why over 7 factorial?
I don't know. My hand just happened to light the 7. Sorry, so it should be 2 factorial. Okay. I feel that when you do P&C problem, all these permutation thing, always be on the more conservative side, safer side. Don't just jump into the pool and start to get the pattern out. Because some of these if you don't put into cases, we may not see some of the details. You get what I mean? Yeah. Kai Xing, okay?
Yeah.
You can? Yeah. I encourage you all, let's say you do your own practices, you do by cases. And if you can, think of a second method. Okay, so there'll be always that first and second method, then you can sort of like counter check the method.
Wait, is it possible to like, can you okay, like Kai Xing's one first, right, which is a 7 exclamation mark, 7 factorial over 2 factorial 4 factorial.
Yeah.
Like then from there, right, this is the combinations assuming that 3 is not there. Then from there, can you times it by like the then after that, if 7 is not there, okay, wait. Give me a second. Okay.
If the 3 is not there.
Like can I do it by like swapping? Like you say 3 can be in any of the order, right? So basically like as long as 3 is not in front. So it's like how to say, okay, I will
Isn't it the complement method?
No.
Is it the same thing?
She's trying to say
okay, so like I have picture here. Okay, so like sorry, can make bigger, yeah, okay. So like this is all the even numbers. So 3 can be any of these arrows except for the front because 3 cannot be in front. So it's 1, 2, 3, 4, 5, 6, 7. So it'll be like something. I don't know. Then you times it by the first one, by the 7 factorial over 2 factorial 4 factorial. Is that possible?
Yeah, is it possible?
Yes.
Understand?
Wait, but I don't know what that. How do you do the swapping thing? Is it 7 choose 3?
Yeah, so your 3 can
7 choose 1. Yeah.
Can be slot.
Yeah.
Oh yeah, it's
Yeah,
7 choose 3. Oh.
Wait, this 7 choose 1. Is it
But
7
it can-
choose
7 choose 1.
7 choose 1. Yeah. So it's 7 factorial 2 factorial 4 factorial times 7 choose 1.
Yeah, so you have to multiply another 7
Is
here.
it the same thing?
yeah.
Yes, should be able to do
Wait, why?
and
Why 7 times 7 factorial over 2 factorial 4 factorial?
because this one is she's trying to take the 3 out. So if the 3 is taken out, then all the digits will be even. So regardless of which is in front, will be all even starting digit code words. You get me? So this will be the arrangement of all the digits without the 3. Then after that, you have to still put in the 3 back because the 3 is in part of the code word. So in this case, but your 3 cannot be slot into the first place, right? So the 3 only can have 7 other positions to slot.
Okay.
You understand? Mingzi? Mingzi understand? Hey, you all must let Mingzi talk. Okay? Yeah. Can? So got it? Yeah, so there are different ways to do it, but you all are too advanced using what slot method, what complement method. So advanced. You are looking at just down.
Actually, I don't understand Bernice one, but I just say I understand.
Oh, you don't understand?
Cause later you go through it anyway.
Huh? So you understand?
Right.
I don't understand.
I don't understand.
No, huh? Oh, you see, Bernice
Yeah.
angry. She went away. Yeah. You don't understand?
No, it's okay. I will wait for later.
Oh, because I think he'll explain later. Later there's another.
Yeah, he will.
Okay.
Like, I know it
But
exists,
yeah,
but
it's before complement. Yeah.
Yeah.
yeah,
It won't be the
okay.
same problem, so you have missed the boat.
Yeah,
The boat
okay,
is off. Okay.
okay.
Yeah. Here is if you want to talk about other objects to arrange them, permutate them, taken from n distinct objects. So this is your formula. Of course the direct formula is NP_R. Okay. But usually people don't, I don't know whether you use this formula in your work. Okay. But for us we usually use it because it's a little bit dangerous to use it. So normally we'll do the choose and order method, which is this one. So choose first.
Oh, usually I use the second one.
This one,
Yeah.
Okay, we will see, that for example, this question, how many 4-letter code words can be formed from the letters here? Yeah, so all the letters are distinct. Therefore, you have 7T4, is it? For grander.
Yeah.
Yeah. Okay. Or you can say 7 choose 4 first. Then after that 4 factorial. They would get the same answer. Yeah. Okay. So,
wait, how does the second one work?
Because when you say 7 choose 4, you are choosing 4 distinct letters. Then after you chose, you still have to put them into their positions. So you are actually putting 4 letters. Yeah.
Thank you.
Okay. What happened to Bernice? Okay. Now Mingxi, have a try, okay? Yeah. So how many ways can a group of 10 people be seated in 2 cars with the first car is a normal 4-seater sedan car. Okay, and the other one is a 7-seater.
Do their positions in the car matter?
What do you think?
No.
If they never say, that means they matter because physically they do have different positions to sit. Yeah. I mean if you look at like that common experience, right, you'll find that when you sit in a car there are different seats. Yeah, they are not the same. Okay, so you have this one. The thing is that how come there are 10 people, there's an empty seat? There's one empty seat. So how many ways to sit them? The rest think about it also.
10 choose 4 times 4 factorial.
Okay, then
then times 7 times 6 factorial.
Okay.
Then plus.
Okay.
10 choose 3.
You continue.
10 choose 3 times 3 factorial. Then then 7 factorial.
So when y'all do all these questions, I advise y'all to really write a short note of what those mean. Okay, what those things mean. For example, here, what this is that the sedan car is full, right? Fully occupied. Is it? I from the impression of this case.
Yeah.
Yeah, then this one is the sedan car is not fully. It's not full. Okay. Anyone? Any dispute?
Yeah, I just did it by 10 choose 4 times 4 factorial times 6 factorial. I didn't factor in the second case.
10 choose 4 times 4 factorial times
Yeah,
6 factorial.
yeah.
I thought it's the other way. As in, I thought that it's 10 choose 4 times 4 factorial times 7 factorial. Then plus
oh, okay, plus
10 choose 3 times 3 factorial times 7 factorial.
oh, so this one and this answer quite similar, huh? Yeah. Okay, this is for fully. Then Bernice got a different answer.
Hey, wait, sorry, Mr. Lau. Change the
I
10
don't
choose 3
have
times
answer.
3 factorial to 4 factorial.
This one?
Is it not the oh?
Yeah, 4
What?
factorial. Yeah.
Mm.
Okay, yeah. It makes sense.
Makes sense, huh?
But why is wait? I don't get the orange one.
Okay, this one, okay. First of all, this one is no, cannot. The reason is this part is the 6 factorial will have problem because the 6 factorial is to arrange the 6 people, but because you choose 10 choose 4, you only have 6 people here with 1 additional seat. So when you do the permutation, you have not accounted for this additional seat. Yeah, you get me? Mingxi? Yeah, so this one will have some problem. Yeah, same for here, 10 seats, then you'll have a problem because you only allocated 3 people in the sedan car, so you have 4 seats, so you cannot use 3 factorial. Okay, then Kai Xing the one, then it's the same, somewhat same type of problem. Then when you choose that time, you didn't consider 2 cases. I think must have the 2 cases lah, if you want to do. Okay, then this is the grander one. Grander is the most promising answer. Okay,
But it's still wrong.
Still wrong, huh? 10 choose 4 people into the sedan car to fully occupy it, then 7 factorial, then 10 choose 3 not fully occupied. This is correct.
Huh?
This is correct. Okay, correct.
Okay.
Yeah.
Actually, I still don't understand why you must times 7
Then I take
factorial
away the
after.
trophy you can take. I don't know.
Yeah, please do.
Cannot, eh?
Yeah, take away.
Cannot. I
Yeah.
don't know the.
Can give me penalty.
There's no penalty.
So the thing is the same. Oh, it's not the same. Right.
What is not the same and same?
It's not the same. Oh, I get it.
You always have your self-revelation. Okay. Okay. Any question? Is there this sort of question?
Like, I don't understand.
Yeah.
Why you have to
I
times
get
7
it, okay.
factorial afterwards?
Because there are 7 seats. Even though there are
So
6
it's
people.
Yeah, okay. So okay, I get it. Okay. So pretend that the empty seat is also a person.
Nah, you get it?
So like
yeah.
yeah.
I know, but then do you have to put like because it's 6 choose 6 is just 1, right? Is that why you don't write 6 choose 6?
You, not
But
me.
technically, me lah.
Yeah.
But there's technically a 6 choose 6 in front, right?
Yeah, technically, but we will not choose because it's just obvious lah. Obvious.
Okay lah. Okay.
Yeah. So actually, whoever doing this working, he or she knows the concept of dummy object. Can? Dummy object, So Missy, your school learn this dummy object strategy. Yeah. But there's a no, but there's a even like you can actually use 11.
Oh,
Yeah, because the dummy person is just a dummy person, and it's going to be different from the rest of the live people. Yeah, so you can have a 11 choose 4. When you have 11 choose 4, you have taken into account whether the dummy is in the sedan car or the other vehicle. So after that, you
Oh.
Yeah.
then this will
So
be
like
one solid step.
y'all can it can be the same order of people, but the position of the seat that remains empty is always changed also. So
Yeah.
it's basically another person.
Correct. And
Then you don't have to minus off the dummy.
no need. Because the dummy you can treat as precisely a dummy, you see. So the dummy will be allocated the empty seat.
Oh.
like a
So
person.
like any. Oh.
It's a ghost lah.
So you assume that the dummy is given the empty seat.
Yes, correct.
Yeah.
You think that way.
Oh.
Okay.
Okay.
So,
But how do you know?
How do you know?
How you know that the dummy is given the empty seat?
You just treat another person as not there. So that person is like
Oh,
not there.
so whoever is in the seat will be the dummy lah.
Correct.
Yeah.
Correct.
Correct. Like the empty person is the empty seat is actually basically another person.
It's the 11th person lah.
This is only
Yeah.
one empty seat, right? Yeah.
Can Kai Xing okay?
Yeah.
Then this is a good strategy, but it doesn't work if you have 9 people.
If you have two empty seats.
Yeah. Then you
Oh, okay.
different really.
Why?
Yeah.
Because
Wait, why
Because
you?
the empty seats are two of the same person. So like there'll be a problem because you are treating them as unique people. How to say? You're treating if you treat both of them as unique when they're actually the same.
do you get me?
Yeah.
Yeah.
But what if you instead of doing like okay.
Because if you have two empty seats, then you'll find that when you start to arrange the empty seats, you'll have a problem whether you want to count the repeat or not to repeat. Depends on where are the empty seats. Can you get me?
Yeah.
Yeah. So
Can you still use like the dummy method for the 9 people, but then you times 2?
no. It's more difficult already because here you have to really sort of like categorize them into which seats are empty and so on. Okay, which car
Okay.
has empty seats? Yeah, is it 1 or 2?
Okay.
Yeah, okay.
Okay.
Different. But if there's a 1 empty seat, you can always think of a dummy. This strategy, I think it's quite interesting. Okay.
Okay, thank you. But then if it's two empty seats, right? Then case 1 is that the first car doesn't have seats. Case 2 is the second car doesn't have seats. Then case 3 is both cars don't have seats. Sorry. Case 3 is the first car has no empty seats. Then
The
Sorry,
first
I'll
case is if the first case
Seat.
is if the first car have no empty seat, and second case if the second car have one empty seat. Anyway, yeah,
Like that.
the one that is choose for is the
then after that is 1, right?
Yeah.
Oh, okay.
Always
Yeah.
go by the
Okay.
safe side. That might be an easier method to do or faster, but very dangerous. Okay. Can so okay, this one I'm just going through all these different situations. Actually, if you look at the more complicated situations, they're actually built up from all these basic situations. Okay. Yeah. So
Okay.
if you know the basic ones, then this is what we are doing also. We are not like know everything. We also try to think about the familiar situations we have been at, and then we build up from there. Okay, here, if you want to talk about n plus m distinct objects to permutate with m of them grouped together, this is your grouping method, which is I think most of you familiar, right? Yeah. So there'll be always an what is it? Yeah, okay. So that is the description. Example, in how many ways can the Tan family of 4, Lee family of 3, and Chong family of 3 be arranged in a straight row for photo shoots if the same family were to stand together? So this is your grouping. Okay, your grouping. Then how to do this question? So I pass it to who? Ming-Si again. Ming-Si. Ming-Si. Mincy. Okay. Wow. Yeah. Why? You also want to come out? Fight against her.
Oh, is it? Wait, do you answer? Sorry,
Okay.
sorry. I was.
Oh,
sorry,
you cannot
okay.
be pushed in front. Okay.
Wait, what?
Is it? Can you see yourself?
Sorry, I can't hear you.
Oh, it's okay.
Okay.
Can you hear me?
Yeah, I can hear you.
Yeah, I say you cannot be pushed in front. Okay. Oh, y'all cannot see. Y'all can see each other or not?
Yeah.
Can.
Yes.
Can you see me moving, Bernice?
Can. No, Mincy.
Oh, cannot.
Me
Okay.
see.
Okay.
I said I'm still the same.
Yeah, you're still there.
Oh yeah,
now
she just
Mincy-
moved back.
Mincy move back.
Okay.
This is so weird.
I actually tried to drag Bernice in front to occupy the
Answer.
slot for Mincy. Yeah, but she cannot.
Oh.
Mr. Lau, can you expand the screen?
As in?
The worksheet, the screen.
Why? I think the board is this.
Oh, can move it. Okay, never mind, it's okay.
Wait. Yeah, this one. I can only expand until like this.
Oh. Okay.
Okay, come, Mincy. Don't worry lah, okay? We can talk anything.
Yeah, I also don't know.
Yeah, also.
4 factorial plus 3 factorial plus 3 factorial. Then bracket the whole thing.
Okay.
Times 3 factorial.
Wow. Oh, okay. Bernice, correct? Or no?
I think so. I mean, at first I thought everything is times together, but I think I'm wrong.
Yeah, I also thought it was all times together.
Yeah,
but then now looking at Mincy's one looks more correct.
Well, correct.
Yeah.
Then I don't know which one is addition, which one is multiplication rule.
Oh dear. Then we have to consult Kai Xing.
Wait, I think
I did it by multiply though, because I thought if you do times, isn't it when you're adding cases?
Wait,
Okay.
I think it's times. I think it's okay. I just think now, but I think it's maybe times because like
Okay, it's
it
actually,
feels like a lot. So I because it feels like there's a lot. Yeah.
Okay.
But I'm not very sure lah. Yeah.
But no lah. Actually, it's time lah. Why times? Because it's a process. You see, the process is to arrange all the people of the 3 families. So use class. That means you have actually stopped the process. That means you only have what, like 4 factorial times 3 factorial, and then you miss out some people. That type of thing. Yeah, the idea. So if you want to get the number of ways, you need to make sure that you go from start to end, the whole process to finish up, arranging every single person, that type of thing. So if you do that, then yeah, we can start with.
Then what's the difference between multiplication and addition?
Yeah, addition is to like for example, you arrange certain thing, you find that I finished arranging, I finished the whole process, but after that on the hindsight I think of there are some other cases I want to consider. So just like the code word problem just now.
Oh wait, is it addition is mutually exclusive, then multiplication is mutually inclusive?
You can say that, or you can say that they are just processes on their own. They finish the whole process on their own. Yeah, mutually exclusive events that have been completed on their own. Okay. Yeah. So coming back here, so 3 factorial would be the 3 families intra arrangement. Okay. So you arrange them. Then after that, the individual families. Yeah. So this will be the answer. Can? Mincy, take note. Yeah. P&C is very important because it leads to the next topic called probability. Yeah.
Yeah, that one sucks.
Huh? You don't like?
Normal very hard.
Yeah, very hard. Mr. Lau.
Then it will lead you to another
A lot of brain
2
work.
more chapters.
Statistics.
Yeah, they'll be
Yeah.
all using
The
probability.
Venn diagram is very hard.
Can your the brain not bad quite big.
Okay, thanks, Mr. Lau.
Like, I don't cry.
Yeah, basically it's about the same size. You don't believe you measure. Yeah, okay.
Okay.
It weighs about 3 pounds. Yeah. How many ways can the letters Vietnam be arranged such that the vowels are adjacent to one another?
Oh.
Okay, vowels. What vowels? These are vowels. So there are 3 vowels.
Yeah, Mr. Lau, we know.
You know,
Yeah, we know.
3 vowel, 4 consonant. Okay, so Grander, you know. Come, what's the answer?
2 factorial times 4 factorial times 3 factorial.
2 factorial, 3 factorial, 4 factorial. Aiyo. Minxi, can you check? Is it correct?
Wait, I don't know.
Wait, no. Wait, sorry. Wait, I feel like there's I got 3. Wait, I put 5 factorial, 3 factorial.
Yeah, same.
Oh, wait. Oh, because the vowels can be in between, right?
Huh?
Wait,
What?
is it?
Sorry, your name hard to spell completely.
Never mind.
Is it like Mr. Lau?
No,
Sorry,
it's not
I
like
changed
me.
my answer. Is 4 slots, like 4 boxes.
Okay.
Then in between each box is like you have 3 slots to fill in.
4 or 3?
No, 4 boxes.
4 boxes.
Then there's 1, 2, 3, 4, 5 options to fill in.
Why you want to do that?
Then 1 more dot at the back.
You want to separate the vowels or what?
No, yeah, I want to separate the vowels.
They don't want. They
Wait,
want them to be.
Are you doing by slotting?
No.
And this
Yeah.
one is they're next to each other. They're like neighbors.
Yeah, but you treat the vowels as one group, right?
Oh, okay.
But they're neighbors.
Neighbors.
Oh.
Okay.
Yeah.
They're like together.
Oh, so
They're like friends.
So
it's
is it
correct.
5?
Is it the same as this?
Okay, yeah.
No.
I don't know.
Then
Wait,
based
Glenda, your
on
method is 4 factorial times 5 choose 1 times 3 factorial, is it?
Grander's method.
Yeah.
Yeah, I think she's trying to do by that way.
4
4 factorial times 5 choose 1 times 3 factorial.
Okay. Also, who is how about Minxi? Okay, not Minxi. Kai Xing, what's the method?
I just did by 5 factorial times 3 factorial.
Oh, same
Yeah.
Then Minxi, you can figure out already? Minxi must now then look closer. Okay. Anyone using the phone to access this web? Anyone using phone?
I'm using iPad.
Or is it iPad?
iPad, okay. No one using phone because phone is very difficult. Too small. Okay. Yeah. Can?
Wait, how come it's 5 factorial times 3 factorial?
You have to ask her.
Is it cause 4 plus 1 then times 3 factorial?
Bernice?
What? Oh, cause it's the same as just now. Like you treat the vowels as 1. So the rest is 5. So it's 4
Then-
consonants as 1. Then the
Right.
vowels can change amongst each other. So
Yeah.
it's 3 factorial.
We will prefer this method lah.
Oh, okay.
The reason
Can.
is because it's always more direct to answer the question. Okay. Can So this one will have. I like the sound. Okay, give you the sound
Oh, okay.
This one also too.
Yay.
Yeah. Okay. Then we have this part done. That's the grouping method. So we have done some grouping method. What other methods are? This and group method. Identical types. Yeah. So we are looking at this thing called slotting method. Okay, slotting method is done in school, right? All of you learn the slotting method. Yeah. Okay. Slotting method is more for separating objects. Okay. That they are not meant to be together. Yeah. So let's look at this. If you are going to slot, you have to always put the unrestricted objects first, then followed by the objects that need to be separated. Okay. That's a slotting method. Because the meaning of slotting is you must have something for them to slot. Yeah. So this, how can the 4 children and 7 adults be arranged with all the children non-adjacent? Okay, this one who wants to try? Shall we just roll a die? Wait, this is not roll.
Wow. Can roll die, that's so cool.
I try lah, okay? I try to roll a die. No? Do you see a die?
Yeah.
You can roll a die. 2. So 2 is Mingxi.
Yeah.
Okay. If it's 2 again, you see? You have to
If
answer.
it's 6, it's also Mingxi, right?
No, 6 will be 1 will be you. Grander 1. No, Mingxi.
No, again. Just now was Mingxi. No, again, just now was
Oh,
Mingxi.
Okay, Mingxi.
7 factorial
Okay.
times times 4 factorial.
Why 4? Now 4 factorial is part of the process, but there's still something missing.
Times
The position of the children. Okay. Can any dispute? I think we will pass the bill. Good. Well done. Okay. Can next one.
Wait, actually, Mr. La, I don't really understand.
Who? You. You don't understand. Because this is we always arrange the non-restricted party first, so there'll be 7 factorial.
Yeah, the 7 factorial, yeah.
Okay, then after that, 8 choose 4 is because of the 8 slots created that you will slot the children in. Yeah, because there are 4 children, so you will choose 4 slots out of the 8 slots for the children to settle down. But then among the children, you need to arrange them in the 4 positions.
Oh.
Yeah.
Okay, can. Thank you.
Okay, so next one, this part. Okay, who will do this part? Who wants to try? Oh, quiet. Oh no. Can you see what am I doing?
Yeah, there's a red dot on the screen.
Oh, then now?
Still, yeah,
Oh,
there's a
different.
text collaboration.
Oh,
Yeah.
I want to erase off the red dot. Okay, wait. Okay. And oh no. Okay, never mind. I can't. Okay. Die again. Okay. 5. Okay. 5 is this Grander, Mingxi, Kai Xin, Bernice. Then the order comes again. 4, 5. Grander. Okay. It goes cycle. You see? GM.
Then Kai Xing and Bernice get one less chance.
Yeah. Good one. You see? You have more chances.
No.
Okay, then grander lah.
Okay.
Then
Okay.
oh no.
1, 2, 3, 4. 4 factorial.
4 factorial.
Yeah.
Consonants. Okay.
Where?
Consonants 1, 2, 3, 4. Yeah, there are 4 consonants.
Yeah.
1,
4 consonants in.
3, 4, 5 vowels.
But then like I still have to do grouping, right?
Yeah, not to one another.
Okay. Then I arrange the 5 vowels first. So it's 5 factorial.
Okay. Okay, good. So it's
Five
a non-restricted party.
Yeah. Then times 3 factorial. Then times where is C4? Times 5 choose 3.
Okay. That's all. Any more?
Times 2 times 2 factorial times 2 factorial.
Wow.
Yeah, that's all.
Okay. Explain why.
Huh?
Explain why,
Oh, the 5 factorial is to arrange the 5 vowels.
Okay.
Then the 3 factorial is to arrange the D, S, and the one group of N. So it's the consonants.
Okay.
Then the 5 choose 3 is because there's 5 slots and 3 groups of consonants.
Oh.
Oh no, five slots. Then out of the 5 you choose. No, sorry. 5 choose 4. 5 choose 4. Because there's 4 consonants.
Yeah, 4 consonants. Okay. Why 5?
Because is 6 choose 4, sorry.
Okay.
6 choose 4, because there's 5 vowels and 6 slots. Then you choose 4 consonants.
This one?
Then I don't know, because I thought that there's 2 N and 2 I. So I thought within one group, you group them together.
Oh. Okay, so
Wait,
question mark.
Is it? Oh, okay.
No, No.
Okay.
Okay. Actually, these two should be divided, not thumbed.
Why?
Because they are repeated one. Repeated objects always.
Oh, okay.
So
Okay.
no trophy. Okay, Kai-Xing, modification.
Is it 5 factorial over 2 factorial?
Answer, that's it, finish. So short.
5 factorial over 2 factorial times 6 choose 4 times 4 factorial over 2 factorial.
Wow. Okay, last person. Bernice, confirm?
Wait, why you skip Mingxi?
No, because just now Mingxi answer one.
Oh, sorry.
Remember the dice too?
Yeah, I had the same as Kai-Xing. Yeah, I answered the same as hers.
Same as Kai-Xing. Okay. So Mingxi, judge. They're going to judge. You have the
same
final
as
say.
Same as Cassie.
Same as, ayo, Grander, what happened?
It's okay.
Yeah, okay. Hannah, I think it's because of this part.
Yeah.
Oh, yeah, this part. But very weird. How come you want to group the two N together? You actually just let them free running around, because they never say the N must be together or not together. So you don't you don't try to put a constraint to them. It'll be very risky.
Okay.
Yeah.
Yeah.
So this one, you understand the working, Brenda?
Wait, how come it's 5 factorial over 2 factorial?
Because of the 2
Because there's 2i, is it?
Yeah.
Oh,
Yeah.
okay.
Then this one you understand.
Then the 2n.
Yeah, correct. So this is
Okay,
the
thank you.
no decision. Okay. Can. You want to take just a short break?
It's okay.
Sorry, I'll be back in 10 seconds.
Okay, it's okay. Look at the next page, huh? Oh, I still have to stop. Oops. Oops.
Sorry, I'm back.
Okay. Oh no, sorry. Okay, can. This one, yeah, this is our favorite method, right? Complementation. Yeah, or complement. Anyone studying bio?
Me.
Oh, do you learn complementation? Mingxi also. In your bio? Have or not? Complementation.
For
I don't know. Because when I search for this word, it came out a lot of the bio terms. Yeah, so I don't know. Okay. Yeah. I never study bio, so I don't know anything. I know nothing. Okay. Complementation is, simply put it, is to calculate the opposite scenario, so that to use the total and minus off the opposite scenario, you'll get the situation that the question wants. Okay, so there's no fixed formula. Yeah, it depends on what you have in the situation. Okay, so let's look at this example. How many ways can a 4-letter alphabet password, so it's an alphabet password, no characters, no other characters, formed such that it contains at least one uppercase alphabet and at least one lowercase alphabet? Yeah, get me? So things like can. So how does a complement, can we use complement or we can use directly the direct method? Okay, so this time we try the direct method. Okay, direct method. How can we find the number of ways using the direct method to talk about at least one uppercase and at least one lowercase? What's wrong with direct method? It's very a lot of trouble and so on. So direct cases will be this one.
Because there can be 3 uppercase, then 1 lowercase. Like you separate into uppercase and lowercase.
Yeah.
Then it can be 2.
Can be 1 3.
Then it can be 1 3.
Okay. We maybe calculate one case now. See how it works. Okay. So this one, who will do it?
Mr. Lau.
Can roll the dice.
Roll die again.
Oh yeah, I can roll the die.
Wait.
Sorry?
Wait, who has the birds? There's a bird sound.
Grander.
Okay, never mind.
It's
I
fine.
really don't have birds. I off my microphone.
Yeah, I think it's mine.
Never mind.
Oh,
Roll the
Kai
dice.
Xing one. Because
Yeah, it's outside my room. I'm sorry.
Oh,
can
okay.
you kill
No, it's
them?
fine. Just pass.
I wanted to, but I don't think it's possible.
No lah, don't lah. We have to save life, not kill them.
Yeah.
Educate them, okay? Please tell them to
Huh.
be a bit more.
I will try.
considerate. Yeah. Okay. So this will be. Oh, that means Kai Xing is doing or what? Oh,
Huh?
3, 1. Oh, ayo,
No.
1.
No. Do again. Mr. Lau, again.
6.
Oh,
Okay, not valid,
again.
Not valid.
Yeah, not valid.
2,
Not valid.
not valid. 5, not valid.
It's either 3 or 4.
1, okay, back to 1.
Not valid. Not valid, Mr. Lau. Not valid.
it's always
Mr. Lau.
Okay, the die is against you. Okay,
No.
can
I really don't know.
Then how?
Is it 3 to the power of 26? Then
Power
you
26.
plus
No,
1 to the power of 26.
no. Why 3 to the power 26? That means you're
Oh, no. It's 26 times 25 times 24 plus 26.
no,
Wait,
Huh?
no.
is it 26 plus 3 times 26 choose 1?
Again, 26.
26 choose 3 times 26 choose 1.
No,
Is it 26 choose 3 plus 26 choose 1?
this one is even worse.
26 choose
Wait,
3.
spam. Mingxi.
Yeah, okay, Mingxi.
Let me see.
Yeah.
No penalty one. If you get it right, you got
26
trophy.
choose 3. 26 choose 3 times 26 choose 1, then times 4 factorial.
Okay, wrong. Okay, Bernice. Okay, first of all, why is it wrong? Once you say 26 choose 3 is wrong already.
why?
The letters can be repeated. They never say cannot repeat. So when you say 26 choose 3, you confirm don't repeat.
So it should be 26 power 3.
Yeah, just now Grander said 3 to the power 26. Not right, Can?
Okay.
26 power 3 and
Times 26.
Is it correct?
Yes.
No.
Wait, do you have the times 3 factorial?
Yeah, times something very good. Okay, remember what are you doing here? You're doing just filling up 4 boxes.
The box.
With the first 3 are upper, last box is the lower case. If you are thinking about that way. Okay, so this is only a first 3 upper, last one is lower. So you need to arrange these letters among themselves. So will be times
3 factorial.
no.
4 factorial.
Okay. Yeah, the
Cause
reason,
why over 3 repeated?
because you are now arranging the kind of objects.
Oh,
you
so the
now.
3 repeated is for the 3 uppercase.
Correct. Okay. Yeah.
Wait, but why is it considered repeated?
Because when you talk about looking at the different arrangements, right, it will not, like for example, even though the ABC are different, But if you are looking at the types, you'll find that it really makes a difference whether the small a is in the first or second or third or fourth positions. Yeah, so
so that's why it's not repeated.
Okay, when you say 26 to the power 3, right, we already sort of like captured the different types of letters to form the upper casing letters.
Okay.
Yeah, but then we still have to look at among the uppercase letters and the lowercase letter, what are the possible positions they can be in. So here we are not looking at the letters themselves, but looking at the kind of letters among the four of them.
Oh, okay.
You get me? You get me? All of you get me? So when you talk about all these questions, you always have in mind the specific versus the general. Okay, so the general is like the what makes up those letters on the surface. Yeah, so the types of letters. Then after that, you'll go to the specific 26, 26, 26, that type of thing. Yeah, okay. Okay, let's try the second case. It's very important to know such a problem. Okay, second case, let's say 2 upper, 2 lower. Yeah, 2 upper, 2 lower. Let's try one more time. Who will go? Who? Yeah, I keep pressing the. I can't find the button. Very nice button. Anyone wants to volunteer? Oh, here you see. This one. Oh. Oh, Mingxi.
Oh no. Wait, I feel like you always kena Mingxi.
Oh, that's bias. Shh. Don't tell her. Mingxi, your turn. No leh. It's just that the slotting machine likes Mingxi. Oh, now you. You want you? You want?
Oh, okay, yeah.
Mingxi lah,
Is
Mingxi.
it 26 for
Mingxi,
Mingxi?
Mingxi. Okay, give Mingxi. If you don't believe, you see, Mingxi will come out again.
No, it's okay.
Oh no.
Mingxi.
Mingxi, hurry up.
Um,
They say you are very slow in the check.
26.
No.
Where?
No, nothing. Okay, this group. Yes.
26 to the power of 4
Wow.
times 4 factorial over 2 factorial times 2 factorial.
Wow. Brilliant. Question? Anyone? Question? Can Yeah. Okay, now you just have to go through the 3 cases, you add them up together, you'll get the answer for this question. Okay. Then but then what about the complement? We are talking about the complement. How does the complement method work?
4 upper and 4 lower.
Yeah. Will it be easier to do complement? Okay, so case 1, 4 upper. You'll find that 4 upper is very simple. It's just 26 power 4, right? Case 2, 4 lower, so it's 26 power 4 as well. Yeah, so what is the answer using complement? It's always the total minus the unwanted cases. But what is the total here?
4 to the power 26.
Glenda, you are making the same mistake again. What 4 to the power 26? 4 to the power 26?
No, whatever.
26 boxes.
I don't know.
26
But
boxes.
how can it be 26 to the power 4?
Cannot. So what else?
26 choose 4.
That's very bad. Okay, let's do it. Oh, Mingxi again. Then Mingxi continue.
Wait 26.
What is the total? What is meant by total?
It's 4 to the power of 52.
Wow. Close. Okay. Yeah, because
Oh, cause 52. Oh.
think of boxes. When you do problems, I think it's good to when they arrange in a certain way, like a row or what. Then think of it physically like boxes and so on. Then maybe you have less chance of making mistake. And each box has 26 plus 26 combination 52. Okay. Can get it? Can you all do a face the palm raise palm? You all got it. Okay. Okay. That means you all alert. Those two are not alert. Okay. So okay, alert got prize. Too slow. Penalty, take away trophy. No lah.
Oh my god. I got a new top.
Okay. Then this one she doesn't want to do it. Okay. Part B.
I got more.
What? What thing?
Nothing.
Yes.
Continue. Nothing. Continue.
There are 9 friends.
Locust me. Okay.
Locust yeah. Okay. May, Lina, Owen, Paul, Queen, Rose, Sam, Tim. They are in alphabetical order, are queuing up for 1-for-1 meal at Swensen. Find the number of ways they can form the queue, such that May, Lina, and Owen are not adjacent to one another, and Sam and Tim are also not adjacent to each other. Yeah. So this one,
I want answer. I want the prize. Sorry.
you want to answer?
I want the thing. Yeah.
Oh,
Yay. Okay. Wait. Give me a.
Wait, Mr. La, go toilet for a while.
okay.
Okay.
The rest try to work out, maybe because she may be wrong. Oh yeah, really you. Okay.